Okay, so we'll go through frequency charts, and three major types of frequency charts are, one is a frequency table, which kind of falls into the other two. It's just the other two become much more specific about the type of frequency table. But you essentially have to construct a frequency table each time, and then we can kind of show the data in different ways, whether it's cumulative or we can do it as a relative frequency. So I've made up some information, averages in a small class. So this class, we've been given some values of their averages. Let's say it's a math class. It's always good to just have an idea of how much data you have. So I'm gonna number it off here, and I'm pretty sure, for simplicity's sake, yes, I took 10 pieces of data. So we have 10 pieces of data here. Now for our frequency table, there's a lot of different ways we can build this. So what we have to do is kind of decide what's the best way to build a frequency table before we start to do it. I could essentially take numbers 1 all the way down to 100 and then take a tally of how many numbers fall are average of 1, an average of 2%, 3%, 50%, 51%. But if you look at these, every single one of these numbers is different, which means my frequency table is just going to have a whole bunch of 1s, which is probably not very good. It's not going to give us a lot of information. So it might make more sense to kind of set up intervals like we had talked about before. Okay. Now, usually you want to use intervals that have the same amount between them. So we know averages in a class, you can really only range from the numbers I wrote before, 1 to 100. So we could kind of set up the intervals. Maybe what we'll do, we'll set them up in terms of 20s. So our intervals, and again, I just kind of randomly generated my intervals. If I had more data, I could potentially do one of everything. I can make my intervals smaller or bigger, but because there's only 10 pieces, I'm going to make the intervals relatively large, okay? So let's say we could go from the number 0 to 20. We can go from 21 to 40. We can go from 41. Whoops, that's not a 1. We can go from 41 to 60. We can go from 61 to 80, and then 81 to 100. Now, if we're talking about letter grades, you're going to notice that really when we talk about letter grades, of something below 50 is usually given the F. That accumulates a lot of information. It actually goes all the way to here. And then like D is like a 10%, C is like a 10%. So letter grades don't really actually break up intervals very evenly. So we're going to take the numeric values. And what we've just done, just be aware for statistical information, we have values that are considered a fail and a pass or a D, all within the exact same interval. So just interesting, not super important for what we're doing, but just be aware that there could be biases involved in how we're taking the data. So from what we look up here, it looks like we're not going to have, did I make any? Oh yeah, we do. We have at least 1 in here, but we're not going to have too much in these lower values. Most of our information is going to be skewed this way in terms of it. Okay, so I'll make a tally. I made this horizontally. You could make it vertically. You could have your 0 to 20, and then your 21 to 40, and then we could kind of use a tally sheet from here. In fact, I'll set it up because that's how they're usually done that way. I just wanted to set up the intervals first. So 41 to 60, 61 to 80, and 81 to 100. Okay, so let's look at values from 0 to 20, and I don't think I have any. There's nothing in there. So this was almost a pointless interval, but we wanted to make them even, so we don't have anything there. From 21 to 40, I think is my only one. It's the number 22, and I'm just going to cross them out as they go, just so that I know that I've done them. Okay, so we have 1 in there. The next interval was 41 to 60. Let's see if we have. Okay, so I have 55, 50, 61 doesn't fall, and 56. So I have 1, 2, 3 pieces of data there. Okay, so in our tally, we're talking about 1, 2, 3. From 61 to 80, we have 1, 2. 61 and 76, so there's another 2, 1, 2. And then finally from 81 to 100, we have 1, 2, 3, 4. Ooh, this is a very successful class. We have 4 pieces in there. I've crossed them out just so I know. So here's our tally of stuff, and the frequency is really just counting a tally. They're pretty much the same thing. if you can tell from here that the number is 1, you don't really need to make the frequency. It's when a tally becomes much larger. So for example, I have a tally of something like this. It can be a hard amount to visually tell what it is, so we just write the numerical value in here, so it's a lot easier to pull the data out of. So I'm going to split them off into kind of columns here. Our very first column for our frequency, we'll put in black. We have 0, then 1, 3, 2, and 3. So we have our frequencies now. This is technically a frequency table. I got all the information I need from it. But let's kind of extend that to a cumulative frequency table. And what could be helpful for a cumulative frequency is, A, we need to kind of know how many pieces of data there are to make sure we've included everything. So if we're going to talk about the accumulation, let's say CU, that's not even how you spell cumulative, it's an M. Let me fix that for short form. There we go. We'll add up another column here. So after the very first row here, our cumulative count is 0. We didn't get any pieces of data. Okay. Then after our second row, we've now accounted for 1 piece of data. Okay. So you can tell for the very first two, they end up being the exact same. It's the next steps that we're going to get different values for. Instead of just taking the amount in that tally, we're going to actually add up the amount in the tally to get our cumulative number. So if you notice here, we now take 1. I'm going to add it to the next frequency. So 1 plus 3 is going to give me the value of 4. So now up to this point, up to the 60%, we now have 4 pieces of data counted for. And the next one, we take 4, we add it to the next frequency, 4 plus 2, that's going to give us 6. Oh, I think I missed something. Oh, this is actually a good example. I made a mistake somewhere, so this is good. And then finally, we take our 6, we're going to add our value of 3 to it, and we have 9. Now that doesn't make sense because I had 10 pieces of data. So I got to go back and see where I missed a piece of data. So this kind of gives you an idea of where cumulative frequency could be helpful. It can be helpful for us to make sure that we included all of our pieces of data. So let me see what we got here. You notice that I didn't put the right tally in here. There should have been a value of 4, which is good. So we checked over our work, blah, blah, blah. Here's our 4. So 6 plus 3 now equals the value of 4, and perfect. We said we had 10 pieces of data. The cumulative value adds up to 10. We've now accounted for everything. Okay. Now, totaling this stuff is essentially what the cumulative data does. You could add up all the frequency. The total of frequency should be the same as the accumulation of everything. So the next thing we're going to build is, again, can all be built in the same thing, is a relative frequency. So for a relative frequency, we need to know our total. It's actually very, very important. Okay. So a relative frequency is another column here. And it's essentially the percentages. Now, I'm going to build it as fractions and then kind of convert them to percentages. So I'm going to move this column over just a little so we have some more room. We know that it's out of 10. So in our very first one, our relative frequency, and again, relative will always refer to the frequency. The cumulative frequency is not really important for relative frequency, and vice versa. Relative frequency is not that important for cumulative. Both of these are always referring to our frequency chart, this part right here, this little table we built. So, relative frequency. How much of the data falls from 0 to 20 in reference of the total? Well, we have 0 out of 10, which is 0% of the data falls within this row here. Okay. For our second row, we have 1 out of 10, which is 10% of the data falls within the 20 to 40 range. Our next one, there are 3 out of 10, which means 30% of our data falls within the 41 to 60 range. Again, 2 out of 10, so 20% of the data is between 61 to 80. And finally, 4 out of 10, 40% of the data, so 40% of this class has an average between 81 and 100. So those are pretty high averages in terms here. And again, your percentages, just to make sure, they need to add up to 100% to make sure you got everything. And because we did it out of 10, it's actually pretty easy to see that they do add up to 100 in this case.